All right. Good evening, everyone.
Good evening.
Good
Good
evening. How's
afternoon, good
everybody?
evening.
Good. How are you? How's everybody? Well, okay. Since I'm sharing my screen now, let me quickly check. There are 9 people here, and let me go back to today's forum. And I thought there were like 10 people in today's forum. Yeah, 10 people. So still one more person needs to join us here. Now, so I have already, I don't know if you have noticed, but I have already posted the quiz one result. And okay, where is it? Okay, it's right here. I don't know if you have noticed, right? Uh, quiz one results and attendance as of, okay, August 3rd. And okay, basically there's a lot of limitations to, okay, here, you see, uh, what is this? This is, uh, the average, right? Average of the first two uh, tests on ROI. They don't directly enter the calculation of the weighted average, but uh, at the end, when I have collected all the data, right, and based on that, if you are at risk of falling below B minus, then I will use this column I to replace the lowest score. For example, this person didn't take quiz one, but at least this person has uh, the ROI test results, the average of the two. And as long as this person takes the other test, then whatever is missing here, it will be replaced by this, right? Uh, I16, right? It will be, so that's how it's gonna work. Um, and also, I've posted. I don't know if you have seen it, but it must. I don't know if it went out, but it should automatically go out when I post something in the announcements. It's supposed to go out automatically. Uh, why isn't it coming out of there? Okay. So in the announcements, you see how to understand your test score and grading system. Uh, so please read that. Uh, I don't have time to go over this in this class. I went over this in Business 210 course, which is runs between 3 and 5:15. So my office hours wedged between that class and this one. So please take a look. All right. So we're now moving on to a new. I think I have uh, this one open already. We're moving on to a new topic, uh, time value of money, and this is the basically the foundations, mathematical foundations of finance. Uh, okay, so now if you go to So we're going into topic 3, and these are the files, right? Uh, so I want you to download all those files, and the Excel file is, quite important. Uh, so let me. So the time value of money is something we've already dabbled. We already dabbled with in topic 1, because to talk about house value and how it grows over time, we have to understand the compounding effect. So basically, we talked about compounding already in topic 1. And just to refresh your memory, just so basically, our question is, suppose you have, you put the principal in the bank, let's say 10K, right? In the bank, which pays, let's say, 10% interest, is, of course, uh, the symbol for interest is R. Of course, symbol for annual interest rate is APR. Um, and then uh, if we keep it there for n years, right? The future value uh, like this, right? Uh, times 1 plus r raised to n. And uh, we talked about this already in topic 1, so it's nothing new. So let's say if n is like 5 years, right? So all you need to do is, so this will be represented as FV5, future value at the end of year 5. So it's 10K times 1.1 raised to 5. Okay? And I don't think it is necessary to go over this again, but the basic idea behind compounding is, and in our house value example, the growth rates each year was uneven, right? In other words, this is, in this example, this R is basically the same thing as growth rate, right? And in our example, in the house value example, G1, year 1 growth rate, it's not the same thing as year 2 growth rate. Year 2 growth rate was not the same thing as year 3 growth rate, right? Not the same thing as, year N growth rate, right? So this was, this is usually the reality if you invest, right? Um, but if you put the money in the bank, uh, the growth rate is even, right? Always, like every year, 10%. This is called, also APR. Not there. I'm not going to put annual percentage rate. Uh, uh, but in topic 1, in house value example, because the actual annual growth rates are all different, we needed to find average of this, right? Average. Remember that? Uh, Finding that average, if we, uh, and then if the average, if we find the average, and that average is called geometric average, remember? Geometric average. Because when there is a compounding effect from growth, over time or through time, you cannot use simple average. You will have to use geometric average. Uh, so once we find the geometric average, we can plug that geometric average there, and from 2000 from 2005 house price by compounding it for 11 years, we could arrive at 2016 house price. Exactly that we arrived at the same thing. So it's basically what we've already seen. Now, so it's not a difficult thing, but we're gonna then look into uh, a little variation. First of all, we will introduce a new variable called m. So what is m? M is the compounding frequency per year. In other words, how many compoundings happen a year, right? Uh, Sometimes, in the past, there was a student who had a hard time understanding what compounding frequency per year means. And then, so he understood it in his own way. He asked me, so it means a cycle. Yeah, you can say you can call it a cycle. How, compounding cycle per year. So we've been assuming that compounding happens so far just once a year. That's possible. I mean, that's quite, um, so if you put your money in the bank for 5 years, then there will be five compoundings. If your interest rate is 10%, right? It's going to be 1.1 raised to 5 to the fifth power. But there can be semi-annual compounding. Semi-annual is twice a year, right? Every 6 months. So compounding frequency M can be 1 or 2 or 4. 4 means quarterly compounding, right? Every 3 months, quarter, right? So there will be 4 compoundings. And then there can be monthly compounding, monthly. And they don't use this, but theoretically, weekly compounding is possible, right? Theoretically. In reality, they don't do this, right? Uh, so it's unusual. And then there is daily compounding, right? Of course, in reality, from you are usually the lender. In other words, you put your money in the bank, right? When you put your money in the bank, of course, savings account will earn interest, but still, even though the Federal Reserve raised the interest rate, Fed funds rate, still it will be a long time for uh, to see substantial increase in the savings rate of the bank. So it's still very mediocre. Uh, but if you put your money in the bank, so because savings rate is so mediocre, uh, the only way you will put your money in the CDs, right? And the CDs generally pay uh, interest. Oops. Their compounding frequency is usually annual or semi-annual or quarterly. That's it. They don't do this. They don't do this. They don't do this. Right? For all practical reasons. Uh, but if you when you borrow, when you borrow, right? When you borrow, not they do even this and even this. So in other words, when it's the bank that uh, collects interest, they, when it's the bank that charges interest, they even use monthly compounding or daily compounding, right? And why? Because the higher the compounding frequency, the greater the future value. Okay, so let's take a look at an example. So I want everyone to, okay, so where do I, okay, so download this file and let's take a look at this. Download the file, please. The file name is time value of money. Oh God, what two files? Just one. What is that? And when you open it, I don't know, it may open in the first tab. I don't know. First, look at the bottom tab, and if your bottom tab, this one is not selected, select that one. Okay. So everyone is on the same page. I want everyone.
Yeah.
To be honest. Good. Alrighty. So,
Yeah.
okay, good. So let's take a look. So this example, uh, that's slightly different from our example, but that's fine. So in this example, still, principal is 10,000, APR, annual rate, percentage rate, 10%. You keep it for 10 years. And this M is one, that means, it's annual compounding. Uh, this one is the same example, but compounding is quarterly, right? 4 times a year. So let's see how much difference, what difference it will make. The first one, we exactly apply that formula. Our future value will be 10K times 1 plus APR, right? R raised to T, okay, time, and hit enter. Okay, that's what it's gonna be 10 years later, right? However, if the compounding is quarterly, I have already something here, but that I'm gonna. I don't know. Do you have this already there? Do you have that filled in? I deleted everything, but somehow,
Yes.
sometimes. Oh, it was filled in already. Then you can delete it.
Yeah, it's all
Delete.
for me.
Okay, delete F3. Now here, let's do. Now, if compounding is 4 times a year, we need to make some adjustment. Adjustment to what? Um, the rate, because each time it's not going to be 10%, it's going to be 1/4 of 10%. Isn't it right? That only makes sense. And then how many compoundings will there be over 10 years? There will be 40 compoundings. 40 compoundings, right? Because there are 4 compoundings a year. So R is APR divided by M. N is T times N, right? In other words, that's the adjustment. We need to make that adjustment. So uh, 10K times 1 plus APR divided by M, right? Close parenthesis, raised to open parenthesis T times M. That's going to give 40, okay? And hit enter. What do you see? Oh, you see, so it's the greater future value than annual compounding. right? The future value is greater when the compounding frequency is higher, right? Makes sense? Uh, so obviously, no wonder why the banks would. Um, okay, where was I think I told you the banks when you borrow money from the bank, right? Or when you lend money from the bank, they um, in other words, you put your 10K into CD. The maximum compounding frequency is 4, right? Maximum compounding frequency is 4. They don't they don't give you more than quarterly compounding. Most of the times it's just either annual or semi-annual. But when they lend money to you, they will do monthly compounding. They can do monthly compounding. Some credit cards do daily compounding, right? And that's why uh, and then here, think about it. So the generic formula for compounding is future value equals p times, right, 1 plus r raised to n. Now, actually, r is generic. R means rate, but what kind of rate? R can be, if you think about it, any rate, because R is the result of APR divided by M, right? If N is 1, annual compounding, it will just be APR. If it is semi-annual compounding, um, R will be uh, 2, whatever, APR divided by 2 or whatever. So this is called, R is called, uh, this is the definition of R, and R is called periodic rate. Periodic rate. So in other words, R is just a generic notation. Generic. It can represent any rate, but uh, I've been telling you over and over, all the rates are all expressed. They have to be expressed as annual. So annual is default. So basically APR is default. But when we actually, depending on what M is, we need to use the correct periodic rate. Excuse me. All right. And, and then um, N N is also the generic notation. N is also the generic notation for our time period. But we all understand N is actually T times M. And what is T? T is years, right? Number of years. Now think about it. Depending on what N is, so N is the actual number of compounding. Actual number of compounding, right? So if time is 10 years, but M is 2, then N is 20, right? Because semi-annual compounding, right? So then 2 compoundings per year. Obviously, over 10 years, there should be 20 compoundings. Okay. So with that in mind, now we know we can handle the next one. Okay. Oops. No. So now here, let's take a look. This one, there was no need for any adjustment because m is 1. But it doesn't hurt to make adjustment. Why? Because if you divide APR by 1, it doesn't change anything, right? Uh, and if you multiply 10 by 1, it doesn't change anything. So what I would do is I would copy this and drag it over. Okay, my mouse is really either sensitive or not acting up, or here. I drag it up and you see no difference. Of course, no difference, but oh, didn't happen. I will drag it up like that. What happened? It's so. Okay, now. So looks like nothing has happened, but actually the formula has been modified to reflect that, adjustment for m. And it is perfectly harmless and nothing to lose. I mean, only but the benefit to gain. What's the benefit? Now we have uniform structure. I mean, across all, for example, if I have a set of problems of the same pattern like this, right? I can do the first one and just drag it down, and then everything will be, right, um, handled by a uniform structure and uniform formula, right, without making adjustment. You don't have to make individual adjustment. It's just done in a single shot. So the uniformity formula is very important because then it makes it reusable. It makes the model reusable, like this one. Now here, what I'm trying to do is instead of making adjustment in the formula, I'm making adjustment already outside the formula. I'm making adjustment to the inputs, right, outside the formula. Then the formula can be maintained. I mean, the formula can still be simple, right? Simpler than the other one. So here, the same example, right? Same example as this. Same principle, same APR, same T, same M. Now, we want to find periodic rate first, which is easy, which is nothing at all. Just divide that by that. And then n periods, n number of periods, right? What's actual number of compounds? T times n. Okay, T times n. And there you go. You simply need to then the generic use the generic formula. P times 1 plus R here R raised to n. Okay, and then hit enter. Voila, you got the same result, right, as this one. But then what's the benefit of this? What I did was I just added 2 more columns, right? Column E and column F. I just added 2 more columns. And then in those columns, I made adjustment directly to the input variable. APR, I made adjustment to APR and T so that I would have them as R and N. And then this formula is now simpler. And the simpler model, so always the simpler model is a better model. Okay? Um, Simpler is not the best word. Rather, as simple as it can be, right? The model that is as simple as it can be is always the best model. Why? It's a structural, think about it. If you are working on a car, if you're working on a car, and if you're a mechanic, would you prefer a car that has a relatively, simpler structure and easier to, simpler structure and uh, something that has uniform and consistent structure, or something that is intricate and a complex system that is very intricate and almost esoteric? Uh, of course, some people might like that. I mean, uh, uh, if you take too much pride in your work, in your trade, and oh, I can work on the car that is, a very, very complex system, and nobody else can figure out the system, but I can. Oh, that's fine, good for you. But then, uh, if you were to fix something went wrong with this car, right? And there was another car, a car with uniform and simpler structure, simpler system, simpler mechanism. Between the two, who's going to fix the car sooner? Obviously, the mechanic who works on a car with a simpler system will finish the job faster. Why? Because it's easier to identify the source of the problem, right? With the cause of the problem, with a simpler structure, with rather than with the complex structure. With the complex structure, it will take more time. It's hard to really identify the source of the problem. And even if you successfully identify the source of the problem, then it's fixing it is also not easy. But if the structure is simpler, easier to identify the source of the problem, easier to fix it, right? So that's why I like this. I prefer I prefer this model than this model. And then if you have basically rows of problems of the same nature, then all you need to do is just copy, highlight those three cells all together, and then, oh, come on, I don't, you know what to do, but I'm not, you just drag it down, bring it there and drag it down. Okay, then you process, or you can solve numerous problems, right, in a single shot, right? Okay, so that's just the compounding formula for future value of annuity. Now let's get back. Then let's take a look at. Okay, back here. Uh, so the base formula is okay. The base formula this is the base formula. Future value is p times 1 plus r raised to n. Now think about it. This formula has future value as the solution. In other words, that means future value is the unknown, right? But then, if you think about it, there can be this is there can be four different unknowns that can be derived this formula. What if p is the unknown? If this is the unknown, that means then everything else is known, right? And then what if r is the unknown? That means everything else is known. What if n is the unknown? In other words, oops, what did I do? Oh, I think I deleted. So This one is the base formula. Let's call it, future value is the base formula compounding, base compounding formula. But what if P is the unknown? How would you find P? How do you solve for that? It's a very straightforward question. Why? I've been telling you over and over, I guess, that the key to solving any equation, right, no matter how complex it may look, you can solve it as long as you can identify z equals x y structure, right? As long as you can identify z equals x times y structure. Because if you can identify the structure, no matter how complex it may look, if you can identify the structure, then think about it. If x is the unknown, then finding x is simply z divided by y. Isn't that right? If y is the unknown, finding y is z divided by z divided by x. And then think about it. What do we have here? This is like z. Isn't that right? This is like x. And the rest of it is like y. It's exactly, you can identify z equals x times y structure. So, question is, what if x is the unknown? Oh, well, if the x is the unknown, we'll solve for, we divide z by y. So, if p is the unknown, right, all you need to do is future value. P is the unknown. Future value divided by 1 plus r raised to n. Okay, so this is called discounting. It's called discounting. And discounting is basically the reverse process of compounding. If you think about it, compounding and discounting are reverse processes of each other, right? I don't know why. I think it froze. It's freezing up. I cannot write anything on it. But you understand why. And when you, so it's a situation like this. You have a target future value. In other words, you want to have $50,000 in 5 years. That's your target future value. You need to have $50,000. And currently the interest rate is, so in other words, your target future value is known, right? It's known. Okay. The target future value is known. Oh, why isn't it doing anything? Okay. What's going on? Maybe I'll, okay, now let me try. Okay, so, I think I will have to switch. Oh, I see. That should have been pressed. So, a lot of things are already known. You have a target future value. It's known. It's 10K. And your timeline is 5 years. You already know. You want to have 5K or 10, let's say 10K in 5 years. And currently the market interest rate is, let's say 10%, right? Prevailing interest rate in the market is 10%. Then I can solve for P. In other words, to have $10,000 5 years from now, what kind of deposit, what kind of principal do you need to deposit in the bank today, right? So it's not a difficult thing. We can solve for that. And when we solve for principal, in other words, in discounting, I told you this is called discounting. Discounting is the reverse process of compounding. And in discounting, because target future value is the unknown, everything else is the known, principal is the unknown, and in this case we call the principal present value. Present value. Why is it called present value? Because that's what the target future value is worth today. That's what the target future value of 10K 5 years from now is worth today. In other words, it must be exactly worth the principal that you put in the bank. In other words, the principal that you have to put into the bank to arrive at 10K 5 years from now, right? That should be exactly the present value of that 10K future value. So this is the second equation that can come from this base formula. And then third and fourth, what if R is the unknown? How do we solve for that? What if N is the unknown? Right? How do we solve for that? It's quite plausible. So suppose, so that means everything else is known. You have $10,000 today, right? Or whatever. I should probably make this 100K. Am I being too? I should make it 100K. Come on. So let's say you have $10,000 today, and your target future value is 100K, and your timeline, your timeline is 5 years. So you want to have, in 5 years, you want to have 100K, but you have 5K, 10K today. So then what kind of interest rate will grow it tenfold, right? 1,000%, tenfold. Isn't it right? From 10K to solving for, we can, and actually, if you think about it, this is the formula you already know. You know this already. You might wonder, when did we do that? You did this. You did that. I'm telling you, you'll see. And then, we will see. And then next question, what about N? So yeah, it's also quite a possible question or doable question or feasible question, right? Feasible question, a question that can arise from this setting. So you have 10K today, and your target future value is you want to grow it to 100K. Currently, the market interest rate is 10%. So how many years will it take? That's all possible question that can come out of this setting, right? So we're gonna do the exercise of the present value first, right? So let me, how do I get out of this? And then, okay. So that brings us to this part where, P is the unknown, right? You see, this is exactly the same example as the previous one right here, right? Under annual compounding and quarterly compounding, we have already the target future value because it's from there, right? In other words, you see, I simply made it equal to E2, so it's pointing to that automatically. And then this is E3, right? It's pointing to that, so it's done. Uh, Now, these are all known variables, I mean, known quantities, and principal is the unknown. But we already know the answer. I mean, it should be exactly 10,000. If we solve for that, it should be 10,000. So we can check, we can check if the formula works. So we'll just do quickly do this one, and we know we can simply because it's the reverse engineering, basically reverse. So FV divided by 1 plus R raised to N. And because M is 1, we're not making any adjustment, but later we will. It doesn't and hit enter. It should come out as 10,000 exactly, right? That's so it checks out. Our formula checks out. Now this one, we need to make some adjustment, right? Because compounding is quarterly. So we divided future value by 1 plus APR divided by M, okay, raised to T times M. T times M. And there you go. Hit enter. What do you expect? It's going to come out. It's going to be exactly 10K. 10K should come out. Hit and 10K. Right? And voila. Right? The formula checks out. So everyone got the same result? Hmm? Tell me,
Yeah.
did you get the same result? Yeah, good. And what about these? You got the same result? In column G, you got the same result? Hmm?
Yeah.
Everyone? Okay, only one person. What about the others? I had at least, like 11 people before I started, when I started. What about the
Yeah,
rest of the?
yeah, makes
Okay,
sense.
good. Okay, good, good. So I have 10 people here and 10 people in the forum. Let's see. Oh, I have 11 in, no, 10, 11. 11 in the forum. So one person isn't yet participating in here. Okay, I think this is a good time to take a break. Okay, so let's take a 10 minute, it's 6:56. 6:56. So I guess we can take a break a little later. I guess I was, okay, let's keep going. Uh, let's keep going for the next one because it's pretty much the same. Now it's the same example. It's the same example. You can see. Oh, uh, future value. Oh, it's the same. Same example. But what's the difference? I just have two more columns for the periodic rate and n. In other words, this time I'm gonna use the simpler formula. Make after making adjustment to the outside the formula, making adjustment outside the formula to directly to the input variable. Okay, so then not a big deal. I'll do this first. Periodic rate is right this divided by m, APR divided by m. It's not dollars. You have to be careful. If it shows, it was then the formatting was not correct. So you just change it to a number. Okay. Oh, but this is percentage, right? This is percentage. So where is percentage? I think you can just do the, there is percentage already somewhere. percentage, and n, actual number of compounding, 10 times n. And then, yeah, it doesn't make any difference when m is 1, but when you drag it down, right, you will, okay, you drag it down, you see it automatically adjusts. So now, all you need to do is, okay, principal, to find principal or the present value, FV over 1 plus R raised to N. Okay, hit enter, and then you drag it down. Okay, so the answer should be exactly 10K. It should check out. So you got the same result? Everyone got the same result? Once
Yeah.
you're
Yeah.
done, good, good. Once you're done, don't leave it just
Yeah,
like that because,
yeah.
okay, good. When I dragged it down, the bottom border was, erased because these, cells didn't have any border line. So to make it neat, I mean, I don't want to make it. I'm gonna use and then border type, the thickest one. The thickest one. This is the thickest one. Thick line. Not the square, but not the entire thing, but just this. My mouse is really acting up. Okay, I'll just okay. Usually, oh, okay. I don't like that. So what I can do is I can use just thick bottom border. Thick bottom border there. Thick bottom border here. Okay, so then it's very nicely enclosed in a box with a border, right? Okay, so if everyone got the same result, now I think it's a good time to take a break. It's 7:01, so we'll take a 10-minute break and reconvene at about 7:10, 7:12. Okay? All righty, let's take a. So I'm gonna. All right, we're back. We're back. So now let's get to our next uh, question. And our next question is about R. How do we find R? Right? So what do we do when R is the unknown? And uh, I told you that this is something you already know. This is nothing new. This is something you already know. How come? You remember geometric average? Hmm? What was what was geometric average? How do you find geometric
Yeah.
average? Yeah,
Um,
ge-
it was future value divided by present value, close parentheses, and then 1/n - 1.
right. And when did you see this? Where did you see this? Okay, so that was DeAndre, right? So I'm gonna give you 1 point for that. So it's FNB 100. Uh, DeAndre, 1 point. Yeah, we saw this already in topic one. And at the time, I just threw this formula, I just threw this formula to you because it will take time. But actually, the other formula was explained. In other words, how you find, how do you solve for, 1 plus g, uh, uh, actually, the result of, uh, 1 plus g raised to n. And let's say if this is, if there is one big number here, we can, uh, we did it, by other formula, but, I mean, explaining how we came to that. I did it with other. Okay, what is this? You don't see this, but on my screen it says power is off in 1 minute to save energy. Okay, no, okay, fine. It doesn't matter. Okay. Uh, my screen was about to go out. I saved it. But the steps of derivation, how we arrived at this, right? That uh, uh, I didn't. So actually, think about it. It involves. So let's go to. How did we arrive at that formula, right? So here's the steps of derivation. So we start with the base formula always, right? Start with the base formula, right? And then this time, this is the unknown. So in other words, the problem is, and I've been telling you, a key to solving all equations is identifying z equals x times y structure. Now, however, you see z equals x times y structure, but then it's not really y. I mean, our y is actually not like this, but inside, uh, you think this is y, but it's more like this. Um, R
Like use.
is inside. Yeah,
Sorry, I was like use ln.
no, not here. It's not for natural log is not something but it's think about it. Uh, you can uh, although we cannot. It seems like then uh, R is inside this Y. You can. So how do we open up that Y? Um, that's something. That's something that first think. But look, first of all, we need to identify. I'm sorry. We need to simplify it as far as we can. We need to simplify. So in other words, um, to sim- we need to isolate this term. We need to, what is, come on. Go away. That, why is it there? Okay, we need to isolate this term. In other words, that's basically taking it, right, to the simplest we can. The first step of taking it to the simplest form we can. So to do that, you will need to divide both sides by p. In other words, currently, if we isolate only y, then we'll have to divide both sides by x. Then on the right hand side, y will be isolated, but so we're gonna, the left hand side will be fv over p. The right hand side 1 plus r raised to n. Now you might think, oh, I turned it into a z over y equals, z over x equals y. But you can also think of it this way. This is now z. This is x, and this is y. So in other words, we have transformed it into z equals x raised to y structure, right? Now, this is a power function now. It's a power function, right? It's a power function, no longer a multiplicative function. This is multiplicative, right? But this is power function. This is power, right? X raised to y. Now our question is that r is inside our x. R is inside our x, and then that means we need to free this r inside x. We must lose n. In other words, we must lose y, the exponent. How do we do that? It's like this. This guy is locked up in a cell, right? So prisoner. R is a prisoner. This guy is locked up in the cell. So this is the cell. This is the cell. And then there's a padlock on it. There's a lock on it. Lock. So if you can open this lock, then this cell will open, right? So how do we open that? So to understand this, we need to review the properties of exponent, right? Let's review the properties of exponent. Okay. First of all, we all know x squared, right, is x times x, but that's not what's simple. If you take the square root of x squared, it's not equal sign. You cannot put equal sign there, but so if you have x squared and you want to know what x is, you have to take the square root of x squared, square root of x. And then we know we can find x, which is the square root. That's why it's called the square root, right? Because it's the root of the squared term. But you think of it, square root looks like this. But originally, the square root needs to have 2 there as well. Why? Because there isn't only square root. There is also, what if there's also third root or third radical, right? Third radical. What if we have x to the third power, or x cubed? To know the cubic root of x to the third power, or x cubed, you'll have to take the cubic root of it, or third radical of it. That is x. It's the same thing. There's a fourth root, right? X to the fourth power. You take the fourth root, fourth radical, then you can find x. And it can keep going like this. If you have x to the nth power, you want to know what x is. You want to know what x is. You take the nth radical of x to the n, right? So that's why square root, originally, if you want to do it really formally, you will have to have that 2 there as well, because there is not only square root, but third root, fourth root, nth root. Now, another way of writing this, so this means square root, right? Another way of writing that is, another way of writing square root is x squared raised to half. Half power means square root. Also, then x to the third power raised to 1/3, right? That's cubic root. It's the same thing, right? It's the same. Simply another way of writing it, right? As I said, this means the third root. Yeah, this means the third root, right? So that means, nth radical or nth root, x raised to n, you take the nth root, you have to do this, right? And the reason that it turns into x is this. One of the properties of exponent is that when you have x raised to a raised to b, what do? It's x raised to a times b. Okay, whereas if you have x to the a times x to the b, it's x to the a plus b. Okay, these are one of the properties of exponent. But think about it. Don't just try to memorize it. There's no way you can memorize all of this. But just plug in some numbers and do some thought experiment. One good example is, try this. What about 2 squared raised to the third power?
2 to the 6th?
Yeah, 2 to the 6th. I mean, according to this, it's 2 to the 6th. But also you can do this. 2 squared is 4, isn't it right? Raised to the third power, 4 times 4 times 4, 4 times 4 times 4. Both of them are 64, right? 2 times 2 times 2 times 2 times, you do that, 6 times, 64, right? 2 to the 6th is, 64. 4 to the third power, 64. 16 times 4, 64, right? So then think about, and this one, also try this. 2 squared times 2 cubed. Then what is this? Before doing this, in your mind, try that. It's 4 times 8. It's 32. Well, what is 32? 2 to the 5th. Isn't it exactly right? 2. I mean, 2 to the 5th, which is 32. So the same thing, right? So do a little thought experiment, and it's quite evident, right? These rules are not there to memorize, but these rules are there for you to reflect. Why it is, why that, what made, what brought the things to that rule. I mean, uh, where did it come from, right? Instead of just memory. So then based on this, think about it. Based on this, what is this? This is, we're trying to take the square root of x squared, right? But then think about it. We know it is x, but why? Use that rule. X to the squared times, right? X to the second power times 1 over 2. And these two cancel out. It just becomes x to the 1. So it's x, right? No matter what. So then x to the nth power, if you want to know the root, in other words, that x, what do you need to do? You take the nth radical, right, of that number, then x raised to n times 1 over n, they cancel out, it just becomes x, right? Makes sense? So why are we talking about?
Yes, Professor.
Yeah, good. Why are we talking about that? Because we were stuck with this question. We're stuck with this. We were stuck there with that. We had over p 1 plus r raised to n. Okay. How about looking at it like x raised to n? How are you going to open this up? By taking the nth root.
Yes.
Right? By taking the nth radical, and then it's going to be x to the n times 1 over n. It's going to cancel out. But here's one thing. You cannot just do it to the right-hand side only. Why? Because it's an equation. That means the right-hand side is equal to the left-hand side. So whatever, for this to hold, right, for this equal sign to hold, whatever you do to the right-hand side, you have to do the same to the left-hand side, right? So if you take the, if you're taking the nth root to the right-hand side, you have to take the nth root to the left-hand side as well. So then, let's take the, let's do that. It's going to be 1 plus r raised to n, the whole thing raised to 1 over n. We're taking the nth radical. And then the right-hand side, 2. I'm not going to put, fv over p right now. We'll just consider that, that the thing in the bracket, right? The thing in the bracket. So we both take nth radical on both sides, and then we know this and this will cancel out. So the right-hand side will become, the right-hand side will become just 1 plus r. Okay? Then what was in the left? So let me rewrite what. So in the left-hand side, we had fv over p raised to 1 over n. In the right-hand side, we had 1 plus r. And our unknown is r. Isn't that right? So how do we solve for r? Well, then we subtract 1 from both sides, or that's how they teach in the United States. But, in most other intellectually advanced countries like, South Korea, or in Japan, or uh, or in Western Europe, or Eastern Europe, where they don't say subtract one from both sides. I mean, yeah, in principle, that's correct. That's not, but that's elementary school. They, the only thing you, uh, in those countries, they say you transfer or move this term to the other side, right? And it's the same thing. It has the same effect because when you move something to the other side, then the sign changes, right? This thing is gone. The sign changes. The effect is the same as subtracting one from both sides. If you subtract one, but it's called transposing. So finally, we isolated because in this country they treat even the grown-ups like babies. Even the teenagers like babies, just pampering, only pampering. Don't stress them out. Right? Don't give them something too hard. Don't stress. No, you have to be, intellectually challenged. Right? That's the only way your brain will grow, by being challenged intellectually. So if there are two things, easier way or harder way, easier way is, you subtract one from both sides, but the harder way is, or more, mature way is, transpose one to the other side. Transpose one to the other side. Right? That's the way to say it. Move one to the other side, then algebraic sign will change. That's the. And then if you explain it like this in the U.S., they don't understand. They don't. Of course, some people will understand. Smart people understand, but the average, because they never learned it that way. Because in high school they taught it like in the elementary school. Subtract one from both sides. Yeah, in principle, that's correct. That's right. But that's not what adults do. That's not how adults do it. Adults do it like, transpose one to the other side. Right? That's the adult way of going about it. So now, eventually, we arrive at what? Okay. We arrive at FV over P 1 over n minus 1, okay, equals R. So finally, we arrived at the formula for R. This is what you learned in topic 1. But, without, at the time, this was G, right? Doesn't matter. It's growth rate. It's the same thing as return in scenario 1. This way, and if you want to, and again, if you think, but isn't it, R is, it looks like we're solving for, no, it doesn't have to be on the left-hand side. I mean, the unknown doesn't have to be on the left-hand side all the time, right? We know this is the unknown. This is the unknown. It doesn't matter whether it's on the right-hand side or left-hand. If you want it to be on the left-hand side, you just rewrite it like that. Okay. Now, so this is why I said in topic 1, I just gave you the formula and I said, there will be a time we'll come back to this and talk about how it was derived. Yes, this is how it is derived. Okay? So if you know how it is derived, the steps of derivation, if you know how it is derived, then you don't have to memorize anything. You can always derive from the initial, the base formula or initial condition. You can always, derive it from the scratch. Okay? All right. So now with that, knowing that, now we can, what is this? Now we can go back to our example, and our example is here. We have two examples, one for R and one for N. But n is going to take more time. I don't think we can talk about n today, but we'll just do, okay? So first of all, so we'll do solving for r. So here, this is the scenario. Oh, you have currently $10,000, 10,000. And you want to grow it to 30K. You want to grow it to 30K in 5 years. So your timeline is 5 years. So what kind of interest rate will take you there? And here, M is compounding is 1, annual, 1 compounding frequency is 1. Then, so there, we don't need to bother with M because M is 1. But later, if the compounding frequency is 4, then we'll really have to make adjustment. But right now, all we need to do is then equal sign. Where's FV? This is, where's my mouse? Okay, my mouse is, I guess it's going to sleep. 30K, 10K. Okay. Now, this is the simple. I've been telling you that's what's happening. Okay, so it just refreshed itself. So FV over P raised to, and that's the universal machine language for raising something to power. 1 over n. N is, in this case, years, 5 years, and it's currently, our formula is above it, so I cannot click it in. And then if you cannot click it in, what do? You just type it in. Then C22, it's in C22, isn't it right? C22 and minus 1. Okay, you don't enter 5, number 5. You don't manually input number 5 there. Why? That you cannot reuse that formula. Isn't that right? It cannot be reused because it is something else. If t is not 5, you cannot use it, right? So for reusability, being able to reuse the same formula over and over, that's important because then you can replicate, right? No matter how many problems, no matter how many problems you are working on, you can do it in a single shot. So hit enter. There you go. This is the kind of interest annual rate that it will take. Now, previously you may remember it was 10,000. Why is it only 30,000? Look, I basically verified. If I use this APR and compound it 5 times, will it take me to that target future value? Yes. I verified that there. And this one, okay, now the compounding is quarterly. What do you need to do? We'll just need to make adjustment, right? We'll just need to make adjustment. First of all, equal sign. You just need to make adjustment to the APR, right? So FV over P, not there, here, raised to 1 over, is it going to be 1 over 5? No, it will have to be 1 over 20. Isn't that right? Because compounding is quarterly, so over 5 years there will be 20 compounding. So, but you don't input 20 manually, because if you do that, it cannot be reused. Okay? Now, I know some of you are taking both classes, in summer too. I mean, I'm teaching Business 210 before this class, 3 o'clock to 5:15. That's Business 210, and then in Business 210 is similar to this, but only half of it. The rest of them is not. And in that it's basically Excel modeling class. And when I give out homeworks, a lot of students, I still see a lot of students input manually numbers in there, like 20. Why? Why do you do that? I mean, if you do that, then it's not going to be reusable anymore. You have to input manually like that for every problem. What a stupidity it is. You build a formula that is uniform and uh, adaptable to any situation, and then you can apply to all the problems of the same type. But if you manually input any number there, inputting a numerical value is called hard coding. If you hard code it, then it cannot be reused. So it should always be soft coding. If it is soft coded, then it can be reused over and over, right? So here, anyway, I'm gonna basically, how do you, 20? We know it's C. I cannot click it in, so I'll just it's C24 times D24, right? That's gonna make it 20. And if the environment changes, then it's gonna automatically adapt to that new environment, right? But if you hard code it, if you manually input those numbers, then it cannot adapt to a new environment, right? Okay, then it's done. Then -1. Okay, then once you hit enter, then something like this comes out. Now 5.65, something's not right. Why? Because if annual compounding, if it takes almost 25%, even by quarterly compounding, it should be something close to 25%, not smaller, something smaller, but not this small. Why? Remember, we used 20 quarters, right? So this is what? This is the quarterly rate, not annual rate. You cannot leave it like this because the label is APR, right? If the label is annual, you should give it as annual. If you leave it like that, who knows this is quarterly, right? From a third person's perspective, a third person coming, just discovering this, will think this is annual rate. And if you are the modeler, it is your responsibility to make it consistent with the, what the label says, right? So then, what do you need to do? Oh, this whole thing is, because this whole thing is quarterly rate, then if you simply multiply it by 4, that's going to turn it into annual. Isn't it right? So you multiply it by M, which is in D24. I'll just have to, because I cannot click it in, I'll just type it in. Hit enter, it comes to something like this. 22.59. So of course, with this verifies that, right? If this is, right, the correct annual rate, then it will take my 10,000 to 30,000 in 5 years. Okay? And here I also did it okay, with the rate function. So again, you remember basically the higher the compounding frequency, the greater the future value. The greater the future value, right? But then if the future value is preset already, I mean, with the same future value as this one, oh, come on, get rid of that review. Don't show. Why is it showing? I'm going to delete that. Okay. All right. Where was I? Oh yeah, I mean, if you start from the same principle and if arrive at the same future value, but higher compounding frequency, that means the rate doesn't have to be that high. The rate should be smaller, right? APR with a smaller APR, that means with a smaller APR, you still get to the same future value, right? It doesn't take as much APR as this. Now, again, for some people who find this onerous, right? Because you have to make all this, adjustments inside the formula. And I told you, no, you don't. Simpler the better. Then let's do this. You just need to add just two more columns so that we can have periodic rate and So here, at least we know what n is. It's t times n. Hit enter. And now we're going to use that formula, right? So FV over P raised to 1 over N. N is already, we know what N is, and that's like F29. If you cannot click it in, you can, right? F29 minus 1. And it's going to give us quarterly rate. Hit enter. That's the quarterly rate. But if the problem was asking for annual rate, it is your responsibility. You have the obligation to answer it in annual rate. And it's not a difficult thing. All you need to do is, let's multiply this by n, and there you go. Voila, we got that. All right? Everyone is good so far? Everyone is following? Everyone got the same result? Everyone?
Yeah.
Okay. Just one person?
Yeah. So far, good.
Okay. Okay, good. Yeah, Isora. Okay, good. All righty. Now, let me. Oftentimes, I don't think we can do n today, but oftentimes, a lot of students ask me, Professor, can we use Excel's built-in function? Yes, you can use Excel's built-in function. Again, but then, as I said, so let's go to a function. You have to make adjustments, and for something like quarterly compounding, what is the periodic rate? You should make that adjustment without. But a lot of students just without thinking, just mindlessly input the data, and that's even the AIs, even the artificial intelligence will think twice and, oh, what is the periodic rate and what is the n? But if you just mindlessly enter the input data, then you'll ruin it. You don't get it. You will mess it up. So future value, select future value, okay, and it's asking for rate. First of all, rate. So then students will put this. I mean, for this problem, there's no problem because it's annual. You can do it, and then comma, and then after that n period. Yeah, they will put this. Okay, comma, and then there's no payment. This is not payment will be for annuity, so there's no payment. So we skip payment, but if you skip, still the comma needs to be there. Comma needs to be there, right? Otherwise, Excel will think whatever comes without the comma, Excel will think the next thing will be payment. And then next is PV, present value. This is the present value. But before you enter present value, you must. This is the thing with the financial calculator. You have to enter negative. Why? This is the distinction between cash outflow and cash inflow, right? Because This compounding is called single cash flow model. Single cash flow means there is single cash outflow and single cash inflow. But think about it. When you put your 10,000 into the bank, it's cash outflow, isn't it right? From the bank's perspective, it's cash inflow, but from your perspective, it's cash outflow. Cash outflow is negative. That doesn't really mean it's negative. It just means it's minus, because it leaves your pocket, goes to the bank, so a cash outflow. You put minus sign there. And that's it. Type, there's no type needed, but put the comma. There's no type needed. That's in case of annuity, there's a type, but in the single cash flow model, there's no type. Just and then hit enter. You get the same result, but then can we get the same result here? You drag it down, let's say. No, you can't get the same. Why? First of all, this is what the students do without thinking. Okay, rate. Look, so they will enter this without thinking. The rate should not be this. Rate is not 10% in this example, in the second case. Why? Because compounding is quarterly. Then you make adjustment like this. And that's the rate. That will make it correct, right? And then end periods. Most students will just put in 10. No, but you'll have to do better. It should be 40 then, right? So C 3 times D3, then it's okay. It's good. And then the rest of it is the same. In other words, you have to make this adjustments. And if you are not alert, if you are not awake, or these days they call it woke, but woke, I think woke is awakened is the correct word, isn't it right? Because woke is used in a gender context, gender equality context, but past participle of the verb wake is waken, right? It's not, or if it is adverb, adjective, it should be awake, right? Woke is just the past form of the verb wake. Isn't that right? I woke up at 7 a.m. this morning. It's a verb, past tense of the verb wake, right? But then the correct word is if you use it in the gender equality context, maybe someone who is alert, awake in that gender issue, right? Equality issue. Well, why isn't it awake, right? It should be awake, rather, But anyway, you should be awake, right? Or alert to this thing, like whether what is the actual periodic rate, and what is the actual end period, right? Without making adjustments for that, then you'll just mess up everything. Also, for present value, yes, this is the same thing. Here, if you want to find the present value, so let me do this one. Okay, PV. You can also find rate. It's not 10%. We know you have to, right? Make adjustment to that, and then comma. Put comma, and then end periods. It's not 10. You gotta put something. I put comma. What is wrong? Come on. Yeah, and then there. C 15 times. Okay, D15, comma, and then there's no payment, so skip, but add comma, and then future value. Okay, now we'll have to make future value negative. If you want present value to be positive, you make the future value negative, right? Otherwise, if you don't make it positive, if you don't make it future value negative, present value will be negative. That doesn't matter, but because that means to have 26, this future value in the future, which will be cash inflow today, this has to be the cash outflow, right? So, and then close parenthesis, hit enter. We get exactly 10K, right? So that kind of, even when you use Excel's built-in function, you should be awake, right, or alert. You should be awake to these adjustments, right? Also the rate, you can find the rate. I'm gonna do it here, okay? And find the rate. Also rate function, right? Rate. And then it's asking for end period. Okay, since I have already done it here. So rate function, end period, it should be not just, you don't put in this, but 5 times 4, which will be. And then we'll skip, that must be a payment, so we skip. And then a present value, I enter it negative, because one thing has to be negative. Present value, if the principal is negative, future value should be positive, vice versa, right? Otherwise it's not gonna work. Otherwise, one thing has to be cash outflow, and the other thing has to be cash inflow, right? Or vice versa. Now, and then that's the end of the formula, right? That's the end of the formula. But I didn't end it there. Why? Because if you end it there, that's when you do it just without thinking, mindlessly. You just follow, and then what you get is not the annual rate, but quarterly rate. That's fine. If the problem was asking for the quarterly rate, that's fine. But as I said, most of the times, the rates must be given as annual. Rates must be given as annual. So to turn it into annual, I multiplied it back by 4. And then hit enter. I come to 22.587, which is, when rounded to the second decimal place, exactly this. Right? So yes, you can use Excel's built-in function, but then
Wait, can you repeat that again because I get lost?
Repeat what?
The sense problem when you give when
Oh,
you
this one?
yeah, that one yeah. How you did that?
Yeah, look, from here to here, right? That's just the formula, Excel's built-in function, right? But if you do that, I told you that will give you quarterly rate, because we are dealing with quarters. It will give you quarterly rate, right? So then you will have to convert it. You'll have to convert it to annual rate, because rates are, by default, rates must be expressed as annual. The problem is asking for annual rate, right? Problem is asking for annual rate, so you have to turn it into so that's why I multiplied D24, right, to turn it back into annual rate. Okay, all right, that you heard that now?
Got it.
Hello?
Got it.
Okay, good, you got it. Okay, good. All righty, this thing keeps coming up. It keeps popping up, so I'm gonna delete it now. All righty. So I guess that's all the time we have for today. and then we can be with a very light mind, lightheartedly tomorrow we can start on the formula for n. Okay. Alrighty. So any if you have any further questions, please send me an email. I don't think I can. We don't have enough time to handle a long question. At this time. Uh,
I have a quick question,
and
Professor.
yeah, yeah.
What day do you think we'll start on the next topic?
Oh, so you mean next topic? You mean topic 4?
Yes.
Um, Most likely, I hope today is Monday, so hopefully by this Thursday, if I can get started on, yeah, hopefully by this Thursday, uh, because we have next topic is bond valuation. Next topic is bond valuation. Uh, October, September 11th, and then we have only 1 week left before the last. I mean, this is our last week practically, and so we have to cram in everything. Um, Bond valuation, stock valuation, all return and risk, all in the last week. So I hope we can. And my office hours are booked until Wednesday. So if the only opening is on the 11th. I hope but again, collaborate session is not the main lecture. I've been emphasizing this over and over. Collaborate session is only a reflection because we cannot do it by, collaborate session alone. That's why I have provided all the lecture videos. I have released it uh, a couple of days in advance already so that you can go ahead and study. And then, you clarify everything. If there was something that you don't fully comprehend, you clarify it in the collaborate session. That is the purpose, right? So this one is already open. This one will be open on the 11th. This one will be open on the 16th. So I hope this will really work like this, and then we won't have any. Okay. Will be we can uh, we can go by the schedule, and we'll be on the schedule, and we'll finish everything by then. All right, so that's it for today. I will see you guys then. I will see you guys tomorrow. Have a great evening, everyone, and see you tomorrow. Okay.
Thank you.
All right. Take care, everyone. So
Thank you,
I'll stop recording.
Professor.
All right. You're welcome. Take care.